In this video, I will share with you some very important points about Q switching of a laser device. First of all, let us try to understand what is meant by Q value. The ability of a laser device to store light photons is expressed in terms of Q value of laser. Larger the Q value, less rapidly is light energy dissipated in the cavity. The technique of switching the laser device cavity from low Q value to high Q value is called Q switching. There are many techniques of Q switching of a laser device. Number one, by using mechanical shutter. Then we have by using saturable dyes. Then by rotating the fully reflecting mirror. Let us discuss these methods one by one. First of all, let us come to how to use mechanical shutter for Q switching. A mechanical shutter is introduced in front of one of the mirrors and the medium atoms are continuously pumped to higher energy state. When the shutter is suddenly opened, a short duration pulse of high intensity is emitted out. It should be noted that if the shutter is opened slowly, then the output will consist of a series of low intensity pulses. Now let us come to the second method by using saturable dyes. This method is also called using passive shutters. The dye having atomic energy levels matching with those of laser medium atoms is added to the laser medium. When atoms of laser medium are pumped to high energy level, the dye atoms also get excited to the same energy level and stay there for a short duration. During this short interval of time, light photons emitted by de-excitation of laser medium atoms are not absorbed by dye atoms and come out of the laser device. When dye atoms are in ground state, the light photons emitted by de-excitation of laser medium are absorbed by dye atoms and so no laser output is obtained. Thus, Q value of laser cavity becomes high or low depending on the state of dye atoms. That is, Q switching takes place due to presence of dye atoms in the laser medium. Now let us come to most popular method of Q switching, that is by rotating the fully reflecting mirror in laser device cavity. In this method, the totally reflecting mirror is made to rotate at very high speed, approximately 30,000 revolutions per minute for a cavity of length 50 cm. The Q value becomes high when rotating mirror is parallel to partially reflecting mirror and Q value is low in other orientations. Sometimes the totally reflecting mirror is replaced by a totally refracting prism, which is then rotated with very high speed. High Q value is obtained when the prism is in proper alignment with cavity of laser device. Now let us come to last popular method of Q switching, that is by using a Pockels cell or a Kerr cell. Both these are known as electrochemical shutters. Pockels cell or Kerr cell are the crystals that become birefringent when subjected to a suitable high DC voltage. This suitable high DC voltage lies between 1 kV and 5 kV in case of Pockels cell and between 10 kV and 20 kV in case of Kerr cell. For example, potassium dihydrogen phosphate, now commonly known as KDP, can be taken as Pockels cell and nitrobenzene can be taken as Kerr cell. The property of birefringent material is that the incident ray of light is separated into two polarized rays of light. One is called ordinary ray and the other is called extraordinary ray. The arrangement for Q switching of laser using Pockels cell or a Kerr cell is shown in this slide. The polarizers P1 and P2 are oriented in the same phase so that both transmit plane polarized light in the same plane. When the cell is off, then light emitted by P1 passes through cell and then through P2 without any loss of intensity. When the cell is on, the light emitted by polarizer P1 suffers 90-degree rotation of plane of polarization while passing through the cell, and so light will not be able to pass through polarizer P2. Thus, there will be no output through partially reflecting mirror. In other words, Q value of laser device becomes minimum when the cell is on and it becomes maximum when the cell is off. The switching time of the cell is so adjusted that the pulses of very short duration are obtained with peak power of 10 to the power 6 watt. Thank you.